Hello, welcome back to the channel. So let's continue our discussion and do some more word problems which are based on differential equations, separable differential equations. So before watching this video, if you have not watched my previous video, I'll highly suggest you to first watch that video in order to get the full context of this video. So again, a basic overview of these type of word problems. The main strategy in order to solve these type of questions is to understand the context of this question, these type of word problems, and then proceed on solving the differential equation by using all the methods that we already covered in the previous videos, right? So in this question, we have been given that a motorboat is traveling with a velocity of 40 meters per second when its motor shuts off at time t equals 0. And we have been given that the deceleration, the negative acceleration due to water resistance, is given by this equation over here. And it makes sense as well, right? If the motorboat is traveling and the motor shuts off, then the speed would be decreasing, right? The speed would definitely be decreasing as time increases, right? So that is why our dv by dt, which is a change in velocity with respect to time, is also negative in this case, because we have been given that k is a positive constant, so k is positive, v square is already positive. So our change in velocity with respect to time is negative, right? And this is the same thing which perfectly aligns with our intuition as well, right? And we have been also given an initial condition that when our time is equal to 0, t is equal to 0, our v is equal to 40 feet per second, right? And then after 10 seconds, the boat's velocity is 20 feet per second. So now based on these two conditions, we'll be easily able to calculate the value of capital C and also the value of this positive constant over here, the value of k. And once we have got the value of k, we'll proceed on to solving the b part of this question, which is to calculate the time when your boat's velocity is 5 feet per second. So that is again a similar type of question that we did in the last video. Again, we'll start with solving the differential equation first. So we have been given that dv by dt is minus k v square. If we move the similar variables to one side, it would be minus k dt. On the left hand side, you'll have dv by v square. And now you can integrate both sides. If you integrate both sides, on the left hand side you have v to the power minus 2 dv. On the right hand side you have minus k dt. So this would be v to the power minus 2 plus 1 upon minus 2 plus 1. This would be minus kt plus capital C. So now on the left hand side you'll have v to the power minus 1 upon minus 1. Right hand side you'll have minus kt plus capital C. So let's simplify this. It would be minus 1 by v minus kt plus capital C. And now we can take the reciprocal on both sides. So v would be minus 1 by kt plus c, negative kt plus c, right? So this would be your final equation of v in terms of t. And now we can use all the given information in the question to solve for our values of capital C and the value of the constant k. So in this question, we have been given that when t is equal to 0, our v is equal to 40, which is provided over here. And we also know that when t is 10, our v is 20. So when our t is 10, our v is 20, right? Which is given over here. So let's substitute that. Let's use the t equals 0 condition first. So v equals 40, t equals 0, so kt term would be 0, and this is minus 1 by c. So your c is negative 1 by 40 in this case. So you got the value of your capital C, and now we can use the second condition over here to calculate the value of k in this case. So we know that v equals minus 1 by kt plus c. So v equals minus 1 by kt, negative kt plus c. C is negative 1 by 40. We can simplify this expression. It would simply be 1 over kt plus 1 over 40. And now we have been given that v equals 20 when t equals 10. v equals 20, t equals 10. So now let's use these values over here. We have been given that when v is equal to 20, so 20 equals 1 over 10k plus 1 by 40. Let's simplify this down. So we can move this expression to this side and this expression to this side. So it would be 10k plus 1 over 40 equals 1 over 20. So your 10k would be equal to 1 over 20 minus 1 over 40. 10k is equal to 1 over 40 again. So k would be equal to 1 over 400 in this case, right? So we have got the value of k. We also have the value of capital C. So we have the final equation as well of v in terms of t. And now we can proceed on to calculate the value of t when our v is 5 feet per second. So let's do that. We know that our original equation is v equals this equation, right? V equals 1 by kt plus 1 by 40. So 1 by kt plus 1 by 40. And now we have the value of k as well, which is 1 by 400. So this is basically equal to v equals 1 upon 1 over 400 t plus 1 by 40. And now we have to calculate the value of time when our v is 5. So we have been given v is equal to 5. It would be 1 over t by 400 plus 1 over 40. Then we can take the reciprocal on both sides to simplify this equation. So it would be t by 400 plus 1 by 40 equals 1 by 5. So the reciprocal of this side, which is this expression, reciprocal of 5, which is 1 by 5. And now we can simplify this equation. So t by 400 will be equal to 1 by 5 minus 1 by 40. T by 400 again equals 8 minus 1 upon 40. T upon 400 equals 7 by 40. This is 10. So t would be equal to 70 in this case. And since the units in this case or for time are in seconds, so t would be, your final answer would be 70 seconds in this case. Again, we use the same approach we followed in the previous question to solve this question over here, which is about knowing or understanding the concept of the question and then proceed on solving the differential equation over here. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.